Hello, and welcome to Module 6.5, Graphing Inequalities into Variables. Our objective is that I can graph the solution of linear inequalities. Vocabulary. A boundary is the edge of the graph. Depending on the inequality, the boundary will or will not be included in the solution set. So, half planes, these are the regions created when a boundary divides the coordinate plane. Okay. Essentially, when we create a linear inequality, it's a line and it's going to divide the plane in half, and it's defined as being in half because it is going to infinity in multiple directions. Now, a closed half plane is the solution when the boundary is included in the solutions. That means it's going to be less than or equal to or greater than or equal to. An open half plane is the solution when the boundary, helps if I'm on the highlight tool, solution when the boundary is not included, and this is going to be less than and greater than. The difference in how we represent these, when it's included, is going to be a solid line. When it's not included, it's going to be a dashed line. So let's walk through the process of graphing an inequality with an open half plane. The first thing we need to do is we are going to identify what is the slope and what is the y-intercept of this inequality. So my slope is 1/2, my y-intercept is +1. So we are going to start with our y-intercept, which is at +1. +1. And our slope is 1/2, so we're going up 1 and to the right 2 every single step. Okay, up 1 and to the right 2. And now we are going to connect our dots. So I'm going to use a thinner line for this. And arrows at the end, and we're going to the edge of the grid. Now, this was a less than, so I'm going to, in yours, you could just write a dashed line. For me, the line tool doesn't quite work, so I'm going to just make it dashed by erasing little parts of it. So, our next thing that we need to do is take a test point, and we are going to test, is this part of the solution or not? So I always look at the test point, if I can, of 0, 0. Why do I use 0, 0, the origin? Because it makes the math easier. It's less steps that I have to do. So I'm going to use a test point. You can always, I would suggest you always use 0, 0 unless the line goes through the origin. So we're going to substitute in 0 is less than 1/2 times 0 plus 1. Is 0 less than 1? Yes, it is. So it is included. So the side that had 0 is the side that we are going to shade as our solutions. So everything below that line is going to be shaded. Now, back in the day when I took this Algebra 1, they just taught us a rule that if it's less than, you're going to shade below or to the left. And if it's greater than, you're going to shade above and to the right. Sometimes that can get tricky depending on how the graph is drawn. It may be hard to tell sometimes what's down or below. So that's why we go about this using a test point, where you are going to substitute in a value. If it works, that is the side that you shade. If it doesn't work, you shade the opposite side. All right, so let's look at letter A. We have another inequality, and my slope is going to be 1. My y-intercept is also going to be 1. So I'm going to start my graph with a point at +1. And I am going to graph it. The slope is 1, so I'm going up 1 and to the right 1 with each and every step that I take. So we're now going to draw in our inequality symbol, or no, sorry, our line. Arrows at the end, because we know we're going to infinity, and I'm going to make mine dashed artificially by just erasing parts of it, because we are less than. And I'm going to substitute in and do some quick math. If it is 0 is less than 0 plus 1, is 0 less than 1? The answer is yes, and so we will shade below our line. Okay? Now, what does it mean? Why is the line dashed? Because points on the line are not solutions to this inequality. A point on the line is not in this inequality. Okay? So, let's look at letter B. My slope is going to be -1. My y-intercept is 4. So we start off with a point at 4, and my slope is -1. So I'm going down 1 and to the right 1 with each step that we take. And so when I graph my line, we take it to the edge of the grid, and I'm going to make it a dashed line because it is greater than. And so I'm going to substitute in my point 0, 0 again. So here's my test point. That's the one that I like to work with. Is 0 greater than the opposite of 0 plus 4? Is 0 greater than 4? The answer is no. So we are going to shade the opposite side. All right, so we did our work there. 0 is not part of the solutions, so we're going to shade up here. So if we just threw in a random number and tried, let's say, let's pick the number that was centered right there. Let's pick 5, 5, right? Is 5 greater than -5 plus 4? Is 5 greater than -1? Yes. Right? So if the point is correct, if it is a valid solution, then we shade that side. If it's incorrect, we shade the opposite side. All right? So let's take a look at letter C. Letter C, we could do this one of two ways. We could try to solve by intercepts, but that one just looks messy right off the bat, and I don't think that's going to work out great for us because 8 divided by 3, that's not a clean number that we can work with. But we can put it into slope-intercept form, so we subtract 3x from both sides. -2y is less than -3x plus 8. And then we go ahead and divide by -2. And we get y is less than 3/2 x minus 4. So my y-intercept is at -4. My slope is 3/2, so I'm going up 3 to the right 2, up 3 right 2, up 3 right 2, up 3 right 2. And so I have my pattern, and now I can draw in my line. And we're going to make it a dashed line because it is less than. And now I need to put in my test point. Whenever you use a test point, always go back to the original equation when you're testing something. That way, if you made a mistake in your arithmetic, you would be able to find it. So we're going to have 3 times 0 minus 2 times 0, and that's going to be less than 8. Well, is 0 less than 8? Yes, it is. So that is the side of the graph that I am going to shade. So, including all of the work, all of this is going to be shaded in. Okay. All right. So, we are going to look at letter D. Letter D is x is greater than -5. So an x equals line is going to be a vertical line at -5, which is right here. So we're going to draw in our vertical line, arrows at the end, and we are going to make it a dashed line. So now we have to decide our test point. Again, is going to be 0. So is 0 greater than -5? Yes. And so we're going to shade to the right of this vertical line. Okay. And your shading doesn't have to be perfect as long as it's clear which side is being shaded. All right. There are now some U-try problems that I'd like you to do on your own. So go ahead and solve them and graph them, and we'll go over the answers. All right, letter E. Y is less than -2x minus 4. So we're going to start off with points at -4. And our slope is -2, so we're going to go down 2 and to the right 1 each step. And when we do that, we have our line. And now I'm going to substitute in my test point, which is 0, 0. Is 0 less than -2 times 0 minus 4? Is 0 less than -4? No, it is not. So we are going to shade to the other side. And I did need to make sure I adjust my line so that it's a dashed line. And there we go. All right, letter F. Y is greater than -3, so it's a horizontal line at -3. And if I substitute in 0, is 0 greater than -3? Yes. So we are going to shade the same side that the test point is on. Okay? Now, we're going to go on to graphing inequalities with closed half planes. These are going to be ones that have a solid line instead of a dashed line. So, letter A. Again, let's find our slope and our y-intercept. My slope is 3. My y-intercept is 2. So I have a point at +2. And it's a slope of 3. So we're going up 3 and to the right 1 each step. And let's just, let's go down 3 to the left 1, down 3 left 1, down 3 left 1, down 3 left 1. And you're going to connect your dots. And this one is a solid line, so I don't need to erase anything. I use my test point because I am not going through the origin. Is 0 greater than or equal to 3 times 0 plus 2? Is 0 greater than or equal to 2? No. So we are going to be shading above this line. And this is where, like this one, would you interpret that as being above the line? Some people struggle visualizing that. So that's what you've got. Letter B. Y is less than or equal to 2/3 x plus 1. So our slope is 2/3. Our y-intercept is 1. So we have a point at 1. And our slope is 2/3. We're going up 2 to the right 3 with each step. And we connect our dots to form our line. With arrows at the end, and we are going to do a test point, which is 0 is less than or equal to 2/3 times 0 plus 1. Is 0 less than or equal to 1? Yes, it is. And so then we are going to be shading on the side with the test point. So we're going to shade down below here. All right. There are 2 you try problems on the next page. Please do those on your own. Go. All right, letter C. Letter C, we have a y-intercept, or sorry, a slope of -2, a y-intercept of 3. So we have a point at 3. Our slope is -2, so we're going down 2 to the right 1 each step. Down 2, right 1, down 2, right 1. And we're going to connect our dots and make our line. And our test point. 0 is less than or equal to -2 times 0 plus 3. Is 0 less than or equal to 3? Yes, it is, so we shade the side with the test point. Okay. Letter D, x is greater than or equal to 1. That is a vertical line at 1. Is 0 greater than or equal to 1? No. So we shade the other side of our graph, the other half. Okay. All right. Example 3 is going to ask us to apply graphing inequalities in 2 variables. So we have for a party, you have a budget of no more than $12 to spend on nuts. You have chosen peanuts that are going to cost $2 per pound, and clearly you have no friends that have allergies. You have cashews, and they cost $4 per pound. What are 3 possible combinations of peanuts and cashews that you can buy? Okay, well, we need to graph, we need to define some things. So let's look at, we've got peanuts cost $2 per pound. We're going to say peanuts are our X value. We have cashews cost $4 per pound. We're going to say cashews are the Y value. So let's go ahead and label our axes right away so we don't forget. Peanuts and cashews. Okay, and we need to write an equation now. We know that we have a limit no more than $12. So let's figure out what we've got here. Peanuts are $2 per pound, so we have 2x plus 4y. We can be no more than, so is less than or equal to 12. So we go ahead and we solve this and we find our intercepts. So if we find our x-intercept, 2x is less than or equal to 12, divide by 2, x is less than or equal to 6. My y-intercept, 4y, is less than or equal to 12, divide by 4. Y is less than or equal to 3. So my y value, we're going to go to 3, and we're going to go to 6 for our x. Okay, and we are going to label in some points here. So we're going to label our scale, obviously. We need to include that. So we're going to have 1, 3, 5, 7, 9, And my x or my y's are 1, 3, 5, 7, 9. All right, so let's graph this. All we need to do is connect our dots on our line, and we get that we have this line, and we're going to shade below it. And the question asked us, what were 3 possible combinations of peanuts that we would be able to use in order to graph or host this party? What are the combinations we could have? So for one example, we could have 1 pound and 1 pound. We could have 3 pounds and 1 pound. You could have 1 pound and 2 pounds. Right? Anywhere in between, under that graph, is a possible value that you could use in order to do this. All right, letter B. We have, suppose you can spend no more than $40 for hot dogs and hamburgers for a picnic. Hot dogs cost $5 per package. Hamburgers cost $8 per package. What are the possible combinations? We know we can spend no more than $40. So when we write our inequality, we have 5, and we're going to say hot dogs are x, so we have 5x, plus hamburgers, burgers are going to be y, so plus 8y, has to be less than or equal to 40, right? The amount that we spend has to be less than the amount that we have. So we're going to go ahead and solve this. Our x-axis is going to be hot dogs, and we're going to go by ones again. 1, 3, 5, 7, 9. Our y-axis is going to be burgers. And again, we're going to do 1, 3, 5, 7, and 9. And let's find our intercepts. If we do 5x is less than or equal to 40, divide by 5. X is going to be less than or equal to 8. So I'm going to have a point at 8. 8y is less than or equal to 40. Divide by 8. Y is going to be less than or equal to 5. So our point is at 5 on our y-axis. And now we draw in our line. You'll notice I haven't done any arrows on the ends of this because can we go below or above, or sorry, can we go beyond the axes? Can we go beyond 0 for any of these scenarios? No, you can't have negative hot dogs. You can't have negative burgers. That doesn't make sense. So that is our graph, and you can pick any 3 ordered pairs that you want on the inside of that graph. So we could say, let's do, 3 hot dogs and 2 burgers. We could do 5 hot dogs, 1 burger. We could do 4 burgers and 1 hot dog. Right? Those are all possible combinations of packages that you could get. All right, if you go to the next page, there are 2 you-try problems for you to do on your own, and then you can check your work against mine. So letter C, we have after their historically bad season, White Sox merchandise is on sale. It's on clearance. T-shirts X are $5 and hoodies Y are $10. If I only have $50 to spend, what are 3 possible combinations of t-shirts and hoodies that I could buy if I wanted to make a poor decision? So t-shirts are X and are $5. Hoodies are Y and $10. And I have $50 to spend. So let's write our inequality. So t-shirts, so we've got 5X plus 10Y is going to be less than or equal to $50. So let's label our axes. Well, let's find our intercepts first. So if I do 5x, no, I'll do it over here. If we've got 5x is less than or equal to 50, divide by 5, x is less than or equal to 10. So I could buy 10 t-shirts. If I bought hoodies, 10y is less than or equal to 50, divide by 10, y is going to be less than or equal to 5 hoodies. So based on that, I'm going to go by ones again as my interval, because that seems to work out pretty well for me. And this is hoodie. And we have our t-shirts. Again, let's go by ones, 1, 3, 5, 7, 9. And we're going to have our point at 10 t-shirts, 5 hoodies, and my boundary line is going to be in between them, and I'm shading below. And what possible combinations can I come up with? Oh, there's lots of them. I can buy, let's say I bought 7 t-shirts and 1 hoodie. I could buy 1 t-shirt and 2 hoodies. I mean, ideally, I would buy, 0 and 0. 0 hoodies, 0 t-shirts, because why would I want White Sox merch? Go Cubs. But if we're going to play within the boundaries, you could say 3 shirts and 3 hoodies is a possibility. All right, letter D. We have Dominique, and Dominique can spend up to $20 to provide the dance squad with drinks after their practice. So, a bottle of water costs $1. A sports drink costs $2, and you can spend up to $20. So let's write out our inequality. So bottles of water, that's just going to be X because they're $1 each. We are adding $2 times the number of sports drinks, and all of this has to be less than or equal to the $20 that you're starting with. So let's find our two intercepts. X is going to be less than or equal to 20. Well, I don't have to do any math there. We could buy 20 bottles of water. 2y is less than or equal to 20. Divide by 2. And so if we only bought sports drinks, we can buy a maximum of 10. So let's take a look at our graph on this. X was water. And I know I need to go up to at least 20, so I'm going to go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So my point on the x-axis is at 20. My point on the y-axis, do I need to go all the way up to 20? Not really. I'm going to just go by ones. So 1, 3, 5, 7, 9, because I can buy 10 sports drinks. And we'll just abbreviate as sports drink, SD. And we draw our line in. And we highlight our solution area is everything below that line. All right, and what are some possible combinations? Let's say we could buy 14 waters and 2 sports drinks. We could buy 6 waters and 3 sports drinks. We could buy 2 waters and 8 sports drinks. Okay. All right, so next up, we're going to go to write an inequality from the graph. So the way we're going to do this, we are going to first find what is my y-intercept. Where do I cross my y-axis? And that's right there. So our b value is at -2. And I need to figure out what is my slope. So we're going to go up 1, 2, and we're going to go to the right 1, 2, 3, 4, 5, 6. So my slope is 2 over 6, which reduces to 1 over 3. And I can see that in between there, I missed one. We can go up 1 and to the right 3, up 1 and to the right 3, up 1, right 3. That's our pattern over and over again. So we have our y. We have our slope, which is 1/3 times x. We have our y-intercept, which is -2. Now all I need is my inequality symbol. It is dashed, so I know it's either going to be less than or greater than. And it is shaded above, so I know it's going to be greater than. Okay. Letter B, we're going to do the same process. Let's find our y-intercept and our slope. So our y-intercept is right here. Our y-intercept is +3. Our slope, we're going up 1 and to the right 2. So that's a slope of 1/2. And we follow the pattern, up 1, right 2, up 1, right 2, right? The pattern holds. Down 1, left 2, pattern holds. It is a solid line, and it is shaded below. So when we write our inequality, y is going to be less than or equal to our slope, 1/2 x plus 3. All right, there is a U-try problem down at the bottom here. The boundary line is dashed and has a slope of 7 and a y-intercept of -2. The area above the line is shaded. What inequality should you write? 30 seconds, go. Now, boundary line is shaded. It has a slope of 7, a y-intercept of -2. Area above is shaded, and it's dashed. Those are all the pieces of information that I just pulled from graphs. So if it is dashed and above, it's going to be greater than. The slope is 7x. The y-intercept is -2. Y is greater than 7x minus 2. That's the end of our notes for Lesson 6.5. It's also the end of our Module 6 notes as well. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.